Hello everyone, in this video I am going to discuss the problem count the trains which came in code forces round 797 and it is 2000 rated on code forces. I explain the question like let's suppose we have some we have array given 10 3 10 13 5 2 6. These elements represent here the speed of each you can say coach, and speed of every coach should be like I can say it should be minimum of speed of this is if this index is I, so its speed should be minimum of AI, or what is speed is available till I minus 1. Like I explained, like speed of this coach will be 10 only, and speed of this coach can 13 or either be 10, and we should take minimum because like its speed should not exceed the coach what is previous before it, so its speed will be reduced to 10. This coach speed is 5 and it should be less than 10, so yes we have 5, so we can put here speed as 5. This coach maximum speed is 2 and it should be less than 5, so it is correct, so we can put 2. This coach speed is 6 and it should be less than 2, but 6 is not less than 2, so we should reduce it to 2. And now we'll find the continuous coaches with same speed. Like here we can see we have two coaches with the same speed. Here we have one coach with speed 5 and again we have two coaches with speed 2. So we can say length number of trains are 3. Basically in question they are terming this block as train and this also is train, and same for this one. And in question we have given that they are giving us m queries, and in each query they are asked to reduce value, it means you can say speed at index I by d. Like if they given us as like 2 comma 3, so let's suppose it's zero based indexing, so we will reduce speed from 5 to 3. So after each reduction of these queries we have to find number of trains. Let's see with an example. Just we should I should yeah. I don't know why it is not erasing. I should erase. Yeah. So let's take this example. This one. So again, I think array is same only as what we have taken 10, 13, 5 to 6. And we have founded that it is speed will be 10. This will also be 10. This will 5, and these two will be 3 and 2 and 2. And in first query they are given that we should reduce value at index 2 by 4. So in problem it is one base indexing, so we should take one base indexing here. Yeah, so we have to reduce value at index 2 by 4, so this value will change to 9. Now we will form our new train, so it will become like this: 10, 9, 5, 2, 2. So total number of trains which exist here is 4. Is this one, this one, this one, and these two combined. Now coming to next query, we have to reduce value at index, well, yes, here. So we have to reduce value at index 5 by 2. So we have to reduce this by 4. So we will see that does not affect our answer because here we have 2, so it should be 2. So again in second case also answer will remain 4 only. In third case it is given value at index 1 should be reduced by 5, means this will change to 5. So now we have to calculate our new values again, like this will become 5, this is 9, which is more than this value, so it will also remain 5. This is already 5, so we can keep it as 5. Here it is 2, so we will put here 2, and here it became 4, but it should be less than equal to 2, so we will make her 2. So now we have two distinct train. This combined is one train and this combined is one train. So here we got 2. In next operation, we have to reduce value at index 3 by 2. So this value, no, not this value, we will reduce by 2. So this will change to 3. And again, we will find our new trend. So it will look like 5, 5, and here it became 3, and this was 2, so this 2 was 2. So here we can see number of distinct train are 3. So answer will be 4423. And you can see yes, this is also answer. Now we have to think like how we can solve this problem. So for that I take some cases, and it is better to visualize this problem. Like if you see what is happening here, like if I have given this array 10, 13, 5, 2 and 6. So here this element is will be always in this means our train. Whatever will be the first element, this will be always included, we can see. So this 10 will be always there. And now when we will move right towards it, we should first take the values which is strictly smaller than 10. Like here value is 5, so that only will take. We should never take value greater than that, because automatically it will get reduced to the lower is equal to 10. So here 5 is available, so we'll take 5. Again, when we will start moving from here, then we should take value which is strictly less than 5, so which is 2. So here we will take 2. Like this we have formed this array, and that is only logic behind this problem. And for like how we will implement this, so I have implemented using set. Like I discuss the solution using my code only, then it is better to understand. Yes, so first I have taken number of elements and number of operation, and I have read the complete values in my vector, and I have taken set, and I have store elements which is strictly smaller than the previous all elements of the array. Like I have initialized this variable with int max, because in the arrays we have values till 1 in 9. So this values is always greater than any value of the array. And as we are getting any value which is smaller than the all the values we got till now, then we will insert it into the set, and we will change this value of HOS to again this current value at current index. Like this we will store elements in the set. Like if we see this example 16, 13, 5, 2, 4. So after this values will become, I think it is 10. Yes, 10, 13, 5 to 6. So after this loop value will become like 10, and again we have 5 and again 2. So these three elements will be stored in this set. Now I will start performing my operations. I will take a input index, and what by what value we should reduce value at that index. I am using zero based indexing, so I done this decrement operation, and I have successfully decremented my value at that index by b. Now I will find a value which is greater than or equal to what index present in the array greater than equal to my current value. Like if I see, if we again take same example 10, 13, 5 to 6. So I am storing here index. So I think here I wrongly mentioned that it should store value, but it will store the index. Like this index is 0, this index is 1, this index is 2, this is 3, this is 4. So in my set index store will be 0, 2 and 3. And let's suppose we are doing at any index, like let's suppose 1. So I will found value which is just greater than equal to this index. Like here if we find, then we will get to that only I done using this lower bound. And now I will do some case work. Like if I am if I getting if there is no element which is greater than equal to this index, like in my array here is 0 2 3, but if I find value which is greater than equal to 4, then I will not get any value, and my lower bound pointer will point here, means at the end of the set. So if that is the case, then I will check a value which is means just before this value, means you can say a last value of the set. And if this last value is like greater than this value what we are getting at this index, then we should insert this element. Like again I take example, like we have taken 0 to 3, so we have element 10, 5 and 2, and we done query for index 4. So if by chance we at index 4 we get value 1, so that should be included in the set. But if we have any value which is greater than 2, like 3, so we should not include that 3 or any other value which is greater than equal to 2. So that only I found, like my pointer is initially like this element is not present, so my pointer is pointing here at end of set, and I decreases my pointer to this element, and I found that is this value is strictly greater than this current value. If that, then I have pushed this element. Like this only I've done. If this value at just at end of set is greater than my current value, so I have inserted this element. And now another case is there this that this lower bound pointer is not pointing towards end of the set, is there is a value present in the set which is strictly greater than the current value. Like again I take an example, then it will be better. Yeah, so again same example I will take 10, 13, 5, 2 and 6, and 0 based indexing 0, 1, 2, 3 and 4, and we have elements 0, 2 and 3, means these coordinates we will store in the set. So like if I'm doing query for this index 2, so element are present in the set which is greater than equal to this index 2. So we will enter into this case. And again I have classified this case in two different type. When my when like if I am querying for this index 2 and this index is already present in the set, that can be the case, or this element is not present in the case. Like initially we have 0 to 3, so if I do query for index 2, then this element is already present in the set. And if I do query for index 1, then element which is present in the set that is greater than this index, but this one index is not present in the set. So these two cases I is separated. So first I will check the case when this index is already present. So like if this index is already present, let's suppose that is index 2. So what we should do, we should like we have already reduced the value of this index. And but like before reducing like this, we have value 10, 5 and 2. So we have some values which are present after this index. But let's suppose after reducing we have changed this value from 5 to 1, because value are always decreasing. So these two should be now not present, because otherwise if we taken this index 3, then our uh, set will be look like 10, 1 and 3. So that should not happen, because value should be strictly smaller than the previous values. So our set will be now reduced to index 10 and 2. So we should remove all the index which are after this index and having value greater than this current value. Like our current index is index A, so uh, I am I am checking from like my current LB pointer is pointing towards original index A, so I have incremented this pointer, and while this pointer is not reaching to the end of the set, I will constantly check that is value present at that pointer is greater than or equal to my current index. If that's so, I will push into the queue, because I cannot remove here. I will remove it later because otherwise it will go to runtime error. So like this only if we change 5 to 1, and in future we have stored element in the set which have value greater than, so we have removed. So this only I done in this case. And another case left when we have value in the set which are strictly greater than the current index. Like if we are querying for index 1, then values what are in the set that are strictly greater than index 1. So we will handle this case separately. And one thing we can become sure that first index will be always present in the set, because this index I will be always present in the set because this is first element. So we can sure that if this element will the present, then if like our a is pointing to first element, then this case will be handled here only, or this in this case above case it will never reach to this else part. So we can comfortably reduce our lower bound to we will find element which is strictly smaller than the current element. Like here for one index which is strictly lower is 0, so we will go from we will go one index back from current index. And again we have two cases, like if that index is less than or equal to current index, then we cannot insert any element. Like we are like I am representing here values, like here some values are like 4 to 1, and my current index value is 5. So when I gone here, I found that these values either is smaller or like is less than or equal to like my current value. So I can never include this index because sequence should always strictly decreasing. So after 2 always any element will come that is lower than 2. Any element can never come which is greater than equal to 2. So that only case is here. Like if there is, if that value is strictly, I mean it is less than or equal to my current value, then I will not do any change, and I will like continue the loop. Or if we'll get enter into the else case, this case will come when value at that LB pointer is strictly greater than the current index. Like we have same example, we can say like 4 2, and here we can say like 0, and here this index we are currently processing, and value here is 1. So it will find here 2, so like which is strictly greater than my current index. So now we can include this index. But like what will happen if we include this index, we should remove all the index which is greater than this value. Like I give by example again, this is not like perfect example to explain that case. So we can consider like we have values 6, 4 and 3, and here what we are processing, it contain value as 1. So like initially in our set value present are 6, 4, 3, but now we have 1. So when we will check one index back, then we'll find that this value great strictly greater than our current value. Then we should definitely include in our set. So our set will become 6, 4, 1 and 3. So this is not correct because this set should be always completely decreasing, but we here one increasing element is there. So again we will remove all the elements which are greater than this index on which we are pointing. Same thing I have done again, like what we have handled in this case to remove all the values. Same again I have repeated here and put this value, and at last I have printed my set side that only will represent number of trains. So yeah, this is all all about this problem. Thank you for watching this video.